Dear students, today we discuss something related about the Young's modulus. What is the properties of the material and what is beam? A beam is a wooden rod or wooden bar of uniform cross section whose length is very much greater than its thickness. It is the thickness, it is the length. The length of the material, the length of the beam is larger is greater when compared to the thickness of the beam. The beam should be in uniform cross section. This type of material is called as beam. In this connection, the question drive an expression for bending moment of a beam. Now consider the wooden beam already that we have seen of breadth B and length L and thickness D. So it has three dimensions, three quantity coordinates. One is length, breadth and thickness. Length is L, breadth is B and thickness is D. A part of the beam is taken like this. The beam is made up of large number of layers. The central layer, this layer is called neutral axis. So consider the position of the beam. Suppose the beam is bent like this into a circular arc. It is a circular arc. The beam is bent like this, and it appears like a circular arc. Its radius. So if you draw a circle, we will have a radius. It is called R from the central neutral axis to the distance is R. The radius of curvature of neutral axis, and this is a theta is the angle suspended by the center of curvature. Is the angle suspended by the angle of suspended by its center of curvature. From the diagram, the A dash B dash is the at the distance x from the neutral axis. See here, it is A dash B dash. It is the x distance. This distance from the neutral axis. This is neutral axis. So its radius ends here. The small x is the distance between B to B dash. So the another layer is at A dash B dash at a distance small x. The length of A dash B dash is written as R plus x into theta. This length A dash B dash is equal to R plus x into theta. And then the original length AB is R into theta. This length AB is R into theta. So the increase in length is equal to R plus x theta minus R theta. We will have x into theta. We know already that the linear strain, the strain is nothing but the increase in length divided by original length. We know that the increase in length is x theta and the original length is r theta. On simplifying, we will have the linear strain is equal to x by r. We know well that the Young's modulus, it is a property of the material. The Young's modulus Q is equal to stress by linear strain. So, from this, the stress is equal to Q into, that is the Young's modulus into strain. Now, we are including the area, where del A is the area of cross section of your filament. Therefore, the force on the area. So, the force on this area del A, the force is given by stress into area. Already stress is equal to force by area. Here, this is simplified. The force is equal to stress into area. So, from this, force is equal to, we know what is stress. Stress is equal to Q into strain. So we have substituted as Q, and this strain is already we have derived here, X by R. So to substitute the value X by R and this area del A. The stress is Q into X by R and area is del A. So the moment of force, next we have determined the force and then moment. The moment of the force about the neutral axis. Moment is nothing but force into distance. We know force Qx by R into del A is the force. The distance is x. So on simplifying this equation, Q del A x square by R. So it is this moment is for the single element. Now the sum of moment of inertia of force acting on all elements. So the summation symbol is put here. So sigma Q del A x square by R. Here the quantity sigma del A is separated. So the Q by R sigma del A x square. The sigma del A sigma A x square is called geometrical moment of inertia. It is sigma del A x square is nothing but a geometrical moment of inertia about the axis through its center and is perpendicular to the plane of bending. It is written as sigma del A x square. It is taken as A k square, which is a constant, where A is the area of cross section. What is K? K is the radius of gyration. What is radius of gyration? The beam is made up of large number of elements. The first layer may have some radius. The second layer may have another radius. The neutral axis may have some other value of the radius, and the last layer may have the different radius. So, depending upon the number of layers, the distance of layers, the thickness of the beam, the radius of the layer varies from inner part to outer part. This cumulative radius is called radius of gyration. This value depends upon the thickness of the beam. So this constant is taken as k square is equal to d square by 12. Therefore, the bending moment of the beam is q by r into ak square. Okay, it is the final expression for the bending moment of the beam q by r into ak square.